let us do a preparation for the exam. We'll do questions and answers. We'll do some exam prep. Okay. So first, let's go start from the basic integral, like 1 4 plus 5x dx. So we'll do obviously a substitution. So 4 plus 5x is our u. Now du becomes 5 dx. Obviously that's substitution because about 1 dx, 5 dx, you can take 5 out in front of the integral. So what you get dx is therefore 1/5 of du. So you have 1/5 and 1/5 is here, and here dx is du, and there we have u. So what's that become? That's, we know that integral of 1 over u, that's different of ln. So that's 1/5 of natural logarithm of u du, which is 1/5 of, that's an absolute value if you remember there, ln absolute value of 4 plus 5x plus c. That's our first logarithm. Oh no, first integral. Now let's do the same, just make this x be x squared. Yeah, so 4 plus 5x squared. For this integral, we take 5 out, so in front of the bracket, so what we do, we'll put 4 in the bracket here, and you have x squared, and if you take 5 in front of the bracket, then you will have that, and the first one will become 4/5, and that's dx. And you're all doing that in order to get what we know, the form that we know. And the form that we know is that the integral of tangents, so the derivative of tangents on x over a becomes a divided by a squared plus x squared. So that's if you do the derivative, and the integral is vice versa, so we want to get this form in order to get tangents on -1. So what we want to know, so we need to write this in a square of something, so that becomes 1/5 integral of 1, and that's square root of 4, which is 2, square root of 4 by square root of 5, so it's 2 divided by square root of 5 on the power of 2 times x squared dx, and that's not yet, because instead of this 1 we need to have this a, so instead of 1 we get 2 divided by square root of 5, but then you need to know that with the opposite in front, so you got square root of 5 divided by 2. Then you can cross that, and here becomes square root of 5. So what that becomes, now we can say that's our arctangents, tangents and power -1. So it becomes tangents and power -1 of x. And what's in the front? That we'll do it later. X over a, and a is 2 over. So if you reverse that, you get x times root of 5 divided by 2, and in front we have 1 over 2 square root of 5 plus c. Let's go to our next integral, and instead of having 1 as the denominator, we'll make it x. So let's see what that will change. So instead of this 1, we'll make it x. So notice that the power 2 and power 1, so whenever you have this, that's ln. If you remember the formula, f prime of x divided by f of x will be some ln of, that's for your integrals, ln of x, something there. So we can do a substitution. So what we're going to do, we will make 4 plus, so let's remove this, I'll make 4 plus 5x squared to be our u, then our du becomes 5x dx. So x dx becomes 1/5 of du. So now, applying this substitution, we get x 1/5 of du, and we have 4 plus 5x squared is our u. So that's our u. And it's obviously that this is the basic integral, and that's natural logarithm, so it's ln absolute value of 1/5 is here of u plus c, and substitute back 1/5 ln of 4 plus 5x squared plus c. And that's our third integral. Let's proceed to more examples. So what will happen if instead of this x, go back to 1, and instead of plus here, we start doing minus. We're going to do so that minus 5x squared. We start doing minus 5x squared. Okay. So what that would be? See, this could be turned, any number can be turned into a square, so it's square of something minus square of something. That we only have plus, so let's put it like that. Now this integral reminds us of arc sine, so sine on the power minus 1, so sine power minus 1 of x divided by a, that's the formula that we know, equals 1 over square root of a square minus x square. So that's the formula. So we need to transform. So that looks similar. So let's transform it. So take 5 out. So out of the square root. So we'll have 1 divided by. So let's first keep one step at a time. So if I take 5 here out of the bracket, and in the bracket you'll have 4/5 that multiplied to give 4 minus x squared, and the dx here. So if you now take the square root of 5 out of the integral, front of it becomes 1 over square root of 5, and under the integral we have 1, and those 4/5 we can write as a power of, so it's 2 over square root of 5, basically square root of 2, no, square root of 4, apologize, square root of 4 over square root of 5 on the power of 2, that becomes 4/5 minus x squared. So times dx, our final solution will be 1 divided by square root of 5 times sine under the power minus 1 of, and our a is square root of 4, which is 2, times 2 times x divided by square root of 5 plus c. I apologize, here the mistake has been made. So it's basically x divided by, so 2 and square root of 5 will change places, right? So it's x divided by, and this is the reciprocal of that. So it's x times square root of 5 divided by 2. And let's do one more. First we raise this one. And the last one for this slide, for this video, will be 1 over square root 4 minus 5x without this square. So we'll make it there just be x. So here we can see that 1 divided by u, so it's ln natural algorithms. So because differential of x always goes to 1, x is lost, so we can do our substitution of that is our u, our du becomes minus 5 dx, and then our dx is minus 1/5 of du. Now if we put the substitutions back, for the x we will have minus 1/5, and 1 is above the line. We'll have du, and down the bottom we'll have this our expression is u, and the power of 1/2. So that's our basic integral. So integral of that is minus 1/5 times u on minus 1/2 because it's under the line, and plus 1. So it's minus 1/2 plus 1 is u on 1/2. Because this is divided by, therefore when it goes up becomes minus u on minus 1/2. U on minus 1/2 plus 1 is 1/2 divided by, so in front of it goes this power 1 divided by what's on the u of power of, so that's only 2, so here times 2, plus c, so it becomes minus 2/5 of 4 minus 5x on the power 1/2 or square root plus c. And that should be all.